Assalamu alaikum. So today we'll learn about definite integrals. What are they, how to write them, and how to evaluate them, and how to use them. We'll do the applications later on. The first and foremost thing, what are definite integrals? How do we write them? You know, all the operations that we have involved in integration, whether it be algebraic, trigonometric, or exponential, or even logarithmic. No, we have the basic logarithmic, but we have integrated and got logarithmic functions. So you see these things, these are different ways of writing definite integrals. Once you do that, we tell what to integrate, the function that needs to be integrated, and this is called the upper limit, and this is called the lower limit. So B
So
is,
what is my upper and lower limits?
yes, and we'll do the applications later on. Right now we are just understanding the notations, what to do with this, why do we write it. We'll do that later on in the applications of integration. So this is something that we do after we have integrated something. I'll just use the example of the book, exercise 15.8, to help you understand what does this mean, because this is a very easy example. Okay, so if I were to evaluate these definite integrals, what do they mean? First and foremost, I need to integrate. So what happens when I integrate this? I get 7x to the power 7 divided by 7 plus c. And because it's a definite integral, I'll write 2 as the upper limit and 1 as the lower limits. So once we have integrated, and if it's a definite integral, this is how we write it. We use long brackets and we write the upper limit on the top and the lower limit on the bottom. Is this clear? So first and foremost, if I'm
Yes.
integrating it, I'm calling it that the function that I get is fx. I'm calling it another function with a capital F. I get another different function, and the upper limit is b and the lower limit is a. Is this clear?
Yes, sir.
Okay, now what to do after this? Once we are done with this, we'll plug in the values. First, we plug in the upper limit, which is 2 to the power 7 divided more. It will just be left with this plus. In the entire function, we'll just plug in the upper value first. The upper limit 2 to the power 7, plus c, minus, then we plug in the lower limit, 1 to the power 7 plus c. So technically, once we get the function after integration, we plug in the upper limit minus the lower limit. Is this clear? So what do we get? 2 to the
Yes.
power 7 is 128 plus c minus 1 minus c. In these kinds of scenarios, will the constant, the arbitrary constant, always be cancelled? Plus c and minus c? Will this always get cancelled? Yes, it will. So once we use definite integrals, we avoid writing the c because we know it will eventually be cancelled out. And this is a value that we get. Is this clear?
Yes, sir.
So we have
Sir, I understand it, but sir, I don't fully get how you do it.
see, once we integrate, these are the operations that we do after integration. And we have to integrate the way we do. After integrating, we get a function fx, right? I'm calling it capital Fx. Then I plug in the upper limit in this function, minus, and then I plug in the lower limit in this function. The applications of integration will help you understand the reasons for doing all these things. Right now, we are just understanding integration and definite integrals. Is this clear? I know you seem a bit confused that why are we doing this? Yes, there is no definite reason or explanation as to why we do this. We will eventually understand the entire purpose once we do applications of integration.
Okay, sir.
Okay, so now let's integrate the next one.
Hello.
Yes, bache. So once you integrate this entire thing, what do you get?
Sir, I got 4, just x upon power 4.
Minus 4x to the power
Yes, sir.
minus
1
4.
upon x power 4.
Sure. Let's see. I hope you're not making an error. So this is what we are supposed to do. We're supposed to integrate this, and we'll just bring the x up. Okay, what happens when we integrate? We increase the power by 1, 4x to the power -2, divide by the increased power, and because it's a definite integral, we'll use long brackets and the limits to show this. And we do not need a plus c, because once we will plug in the values and subtract it, the plus c will be eliminated. Is this right?
Yes, sir.
So this is -2 upon x square, and the upper limit is 2 and the lower limit is 1. Now plug in the upper limit first. -2 upon 2 squared
-1.
minus 2 upon 1 squared. So what does this become? -1 upon 2 minus and then plus 2. So you'll end up getting 3 upon 2. Is this clear?
Yes, it's clear.
Okay, similarly, once we integrate this, what do we get? 5x square upon 2 plus 2x. The upper limit is 3 and the lower limit is 1. Now plug in the values. We'll get 5 into 3 squared upon 2 plus 2 into 3. This is how we plug in the upper limit, minus 5 into 1 squared upon 2 plus 2 into 1, lower limit. So what do we get? Simplify this using a calculator as well. 9 5s are 45 upon 2. 1 upon 2, 40 upon 2. 26 minus 24. Guess beta.
Yes, sir.
What do you
The
get?
1 minus.
So first thing that we decided to do was okay. So first we said let's keep the limits as it is. Simplify the expression. We'll get x to the power 3 upon 2 plus 3x to the power half dx. Now let's start integrating. X becomes power 5 over 2 divided by 5 over 2 plus 3x to the power 3 over 2 divided by 3 over 2. Upper limit is 4, lower limit is 1. We should simplify it before going on. So we get 2x, or we can write 2 is square root of x to the power 5, or just write x to the power 5 over 2 upon 5 plus 2x to the power 3 over 2. And you plug in the upper limit 4 and the lower limit 1. So what is the value that you get? Two into 4 to the power 5 over 2 upon 5 plus 2 into 4 to the power 3 over 2. This is for the upper limit minus the lower limit 2. Yeah, no, when I'll plug in 1, everything will remain 1. So I'm just saving time. So what do you get?
Sir, I got 26.4.
26.4. I'm trusting you with the value. I have not found it on my own. 232, 64, 5. Fine, I'm trusting you with the value. Move on to the next two parts.